So at this point, I'm now pleased to introduce our next speaker, Professor Meng Fan. And with great pleasure, let's hear from Professor Meng Fan. Over to you.
Good afternoon, everybody. So it's my pleasure to present you the fourth periodical report on the state of acid deposition in East Asia. So every 5 years, EANET publish a periodical report. So this one is a fourth periodical report. So covering the data from 2000 to 2019, it's a 20 years data. So basically, this report have a three part. The first part is a regional assessment report, and the second part is a national assessment report. The third part is executive summary. So in 2020, so we established a drafting committee. So there are totally 58 authors responsible for the regional report, and for the national report, it's authors from each participant country contribute. So it's a lot of people's hard work. So basically, the EANET, we have started operation since 1998. We currently have a 20 years data from 2000 to 2019. We have a 5 type of monitoring: dry deposition or air pollutants, wet deposition, soil and vegetation, and inland water, and also catchment, which is for the eco impacts. For the air deposition, we have 66 sites, including 26 urban sites, 19 rural sites, and 21 remote sites in 13 countries. We currently measure sulfur dioxide, NO, NO2, NOx, PM10, PM2.5, ozone, and also PM components, and ammonia, other air pollutants. For the eco impact, we have 16 soil and vegetation sites, and 6 inland water sites, and 2 catchments in Japan and Philippines. Every year we conduct inter-laboratory comparison for data quality, and our data quality keep improving. So those are also described in this report. So next few slides, I'd like to give you a very brief introduction about our results. First of all is acid deposition, wet deposition. So when we're talking about wet deposition or acid rain, we are talking about the pH value in the rainwater or snow. So you can see the left hand, upper left hand, the chart is showing the EANET pH value, and also NADP, which is a US acid deposition network, and also EMEP, which is a European network. So you can see very similar trend. The pH value decreased before 2003-4. So and since then, the pH value will keep increasing, means less acid. So for the left hand, the two chart is nitrate and sulfate in the water. So you can see the concentration of sulfate in EANET is significantly higher than in US, in Europe. So means we still have a heavier wet deposition problem. And for nitrate, in EANET region is similar to Europe, but still higher than in US. Inside the EANET region, so we can see sulfate and nitrate concentration is higher in Northeast Asia. It's much higher than in Southeast Asia. So this is basically wet deposition results. This slide is for the sulfur deposition, so including the dry deposition and the wet deposition. So left hand is a 3 chart. Every 10 years we have a 3 chart. So every 5 years we have 3 chart. One chart is for 10 years. So the first one is 2010. The second one is 2005 to 2015, and the last one is a recent, the current decade. So red dot means a significant increase, and blue dot means a decrease. So you can see for the sulfur deposition, including the dry and the wet deposition, there is a significant increase in Southeast Asia. Even the other part of region is a decrease. So we can see a significant decrease, but in Vietnam and Indonesia, there's some increasing. So means even the level is still low, so it means need more attention. For dry deposition, so you can see on the right hand, the chart, the orange one is a dry deposition, blue one is a wet deposition. So you can see the dry deposition decrease actually is faster, which is directly linked to the sulfur dioxide decreasing. This chart is for the nitrogen deposition. So you can see nitrogen deposition is significant increasing in many sites, except Russia and Mongolia sites. So you can see many red dots, especially the last 10 years. We can see slightly increasing. So this is a problem. Maybe we need to pay more attention. And on the other hand, the most nitrogen deposition is a wet deposition. Means this is a more regional problem, not a local problem. And this slide is showing the air pollution concentration in East Asia from 2015 to 2019. This is 5 years. So basically, for sulfur dioxide, most sites are very low level, even in Northeast Asia. So the sulfur dioxide concentration decreased. Currently, sulfur dioxide not a big issue. But NOx is still high, especially in Mongolia, and we found it's very high. And also Philippines and Thailand, we found a high NOx problem. For ozone, so you can see this yellow one. So it's very interesting. So Korea, Japan has a high ozone, and also the other region like Mongolia, Russia also have a very high ozone than other without polluted region. So this means ozone involved in more complicated process, the chemistry or the background concentration. So it's more complicated. For PM, currently we don't have a very complete PM monitoring, but for the country report PM 2.5, we can see all the PM 2.5 concentration in the region is high, is pretty high. So compared to the WHO's target, so it's still at a very high level. And for the component in the PM 2.5, so sulfate and nitrate in China, Vietnam still at a pretty high level. So it means this is still issue, and this is also closely related to acid deposition. So this two chart actually it's for the sulfur dioxide and PM10. So sulfur dioxide in Russia, Mongolia sometimes report high concentration, and in the past 20 years we see very high sulfur dioxide concentration in China significantly reduced, and in other countries basically sulfur dioxide is low except for Indonesia, so it's a little bit high. And in Mongolia, Indonesia, and Vietnam, recently they report PM10, the high PM10 concentration. PM10 actually is more connected to the coarse particulate, like fugitive dust or wind blown dust. And this slide is ozone and NO2, NOx, NOx, NO2. So as I mentioned, the ozone in Korea and Japan is high, but the other region, so we can see very slight increase. Some Chinese side and some Thailand side, we can see the increasing ozone problem. And Mongolia, Philippines, now we have a high NOx concentration and a little bit increasing. And so basically, this is our report about air pollution. So maybe I need to mention that the sites for each country is not so many. So maybe we need more sites to represent the situation. The next two slides is showing ecosystem, the impact on ecosystem of acid deposition. So the first slide is inland water and forest catchment is also water. So you can see it's a very clear picture. So on the left side, you can see the pH value in the inland water. So decrease means more acid, and then increase means less acid. And we can also see all these iron, cation like sulfate, nitrate, and calcium increase before 2010, and after that, so all this concentration decrease, which is a response to the trend of acid atmospheric deposition. So the next slide is for the soil and vegetation. So you can see, so this is different from the inland water. So we cannot see the very clear decrease or increase pattern follow the deposition. Soil pH did not necessarily increase according to the when deposition is decreased. And we also didn't find the tree growth recover from acid deposition. So this may be so means the soil chemistry property and tree growth are very complicated, maybe due to the natural characteristics of soil and vegetation, and also maybe because the other environmental factors like air pollution, and also maybe changing climate change. So this is a complicated issue. So it means a long time monitoring is necessary. And this slide is showing the we call cross-cutting analysis. Actually, it's between the different chapter of this report and also outside EANET study. So we found satellite remote sensing and very helpful for provide more coverage and for long-term monitoring. So it's very good combined with our monitoring data. And we also found from emission inventory and modeling study, so showing the effect of emission control. So we already from the monitoring data found the decrease of deposition, and we proved from emission inventory and modeling study. And we also found the impact of acid deposition and air pollution, both inside the EANET study and outside in study. So on the ecosystem and health are significant. So it means that we need to continue to conduct our monitoring and assessment study. And we also found the climate change, air pollution, and their impact are actually very complicated and also very closely related. So it means when we conduct monitoring, so we need to consider both air pollution and climate change. So it means that we need more site and more items to measure, and also multidisciplinary study are necessary. So yeah, basically that is my talk. This is a summary. So sulfur dioxide related to air pollution and also air deposition are improved, especially in Northeast Asia. However, the nitrogen deposition, the PM problem, ozone and NOx problem are still at a very high level. So, and also we found the PM sulfur problem in Southeast Asia increased, maybe need more attention. The inland water have a sensitively respond to the atmospheric deposition and air pollutants. But the impact on ecosystem, so it's very complicated, means long-term monitoring. Our data in EANET, data quality is improving. So, but the more site and more item may be needed, and maybe the other technology like low-cost sensor or remote sensing by the satellite, maybe it already showed promising. So maybe we can combine them in the future. And finally, the acid deposition, air quality, climate are closely related. EANET now currently is considering scope expansion. So maybe integrated more monitoring item and monitoring activity combined with the modeling, emission inventory, and other multidisciplinary study. So maybe is an effective way to support control policy making. That is my talk. Thank you. Yeah. By the way, so this PRSAD report is published soon, maybe in 1 or 2 weeks. Please contact us for the hard copy. Thank you.